Have you ever wondered how many secrets does the universe hold? Our cosmos is a vast, enigmatic expanse brimming with phenomena that defy our understanding of physics. Among the stars we find planets where the impossible becomes the everyday. Imagine a world where it rains diamonds or where oceans boil under alien skies. Intriguing, isn't it? So fasten your seatbelts as we're about to embark on an interstellar journey. Let's voyage into the unknown and discover the 5 impossible things that can happen on other planets. Imagine a rain shower, but instead of water, diamonds are falling from the sky. Sounds like a scene from a fantasy novel, right? Well, not if you're on Neptune, the 8th planet from our sun. This icy giant with its striking blue color holds a secret in its atmosphere that's as fascinating as it is bizarre. Yes, we're talking about a weather phenomenon that's quite literally priceless. Diamond rain. How is this possible, you might ask? It all starts with Neptune's atmospheric conditions. Neptune is a gas giant, much like Jupiter and Saturn, but it's much colder, with temperatures dipping to minus 200 degrees Celsius. This extreme cold, coupled with the planet's high-pressure environment, creates the perfect conditions for a phenomenon that's nothing short of extraordinary. Neptune's atmosphere is primarily composed of hydrogen and helium, but it also contains a significant amount of methane. Methane, as you might know, is a simple hydrocarbon composed of carbon and hydrogen atoms. Now, under the intense pressure and temperature conditions in Neptune's lower atmosphere, something remarkable happens. The methane molecules are broken apart, and the carbon atoms are squeezed so tightly that they crystallize to form, you guessed it, diamonds. These diamond crystals then fall through the atmosphere like rain, towards the planet's core. But don't pack your bags for Neptune just yet. These aren't your typical gem-grade diamonds. They're more like diamond dust, tiny particles rather than the large, clear crystals we're familiar with. But still, the idea of diamond rain is something that's hard to wrap your head around. Scientists are still studying this phenomenon and its implications. It could provide insights into the planet's internal structure and energy production. And it's not just Neptune. Scientists believe that diamond rain could also occur on Uranus, another ice giant with similar atmospheric conditions. So on Neptune, diamonds aren't forever, they're just weather. What if an ocean was so hot it boiled non-stop? Picture this, a planet where the seas are not made up of cool, refreshing water, but rather an endless expanse of superheated, boiling liquid. Welcome to Gliese 1214b, a fascinating exoplanet that is home to some of the most extreme conditions in the universe. Located approximately 40 light-years away from us, in the constellation Ophiuchus, Gliese 1214b is a world unlike any other. This exoplanet, also known as a water world, is enveloped in oceans that are constantly at boiling point. But don't be fooled into thinking these are like the bubbling pots on your stovetop at home. The oceans here are under such intense heat and pressure that the water exists in a strange, almost alien state. This isn't the solid, liquid, or gas that we're familiar with. Instead, it's a superfluid, a state of matter that blends the characteristics of both liquid and gas. Imagine for a moment being submerged in this superfluid. The water wouldn't splash or ripple like it does on Earth. Instead, it would flow without friction, effortlessly enveloping and moving past you. And yet, despite this fluidity, the intense heat would make it feel more like being enveloped by a cloud of steam. But what causes these extreme conditions? Well, it's all down to Gliese 1214b's close proximity to its star. This exoplanet orbits its star at a distance of just 2 million kilometers, causing surface temperatures to reach up to 500 degrees Celsius. That's over 900 degrees Fahrenheit. In these boiling oceans, life as we know it would be impossible. But who knows? Perhaps there are organisms out there that have evolved to survive in such extreme conditions. After all, the universe is full of surprises. And so, we leave behind the boiling oceans of Gliese 1214b, a world that challenges our understanding of what an ocean can be. A planet where the seas are a blend of liquid and gas, and where you'd need a heat-resistant swimsuit to take a dip. Gliese 1214b, a place where you'd need a heat-resistant swimsuit. Imagine a storm where, instead of water, you're pelted with shards of glass. Take a moment to visualize that. It sounds like something out of a science fiction novel, doesn't it? Yet this is the reality on the distant exoplanet HD 189733b. HD 189733b is a gas giant that resides approximately 63 light-years away from us in the constellation of Vulpecula. It's a hot Jupiter type of planet, meaning it's similar in size to our own Jupiter, but orbits its star at a much closer distance. It's a world of extremes. with temperatures soaring above 1,000 degrees Celsius and winds howling at speeds of up to 7,000 kilometers per hour. But the real jaw-dropper is the planet's atmospheric conditions. The high temperatures and pressures on HD 189733b are perfect for the formation of silicate particles, tiny bits of sand-like material that are whipped up by the planet's violent winds. As these particles interact with the planet's scorching atmosphere, they condense and harden into tiny shards of glass. Yes, you heard that right. Glass. Rain. The planet's ferocious winds carry these glass shards sideways, creating a perpetual storm of glass rain. If you were to stand on the surface of HD 189733b, a feat in itself given the planet's intense gravity, you'd be subjected to a ceaseless barrage of glass, carried on winds moving at the speed of a commercial jet. The fascinating thing here is that we can learn so much about a planet situated billions of kilometers away. Astronomers decipher these mysteries by observing the way the planet's atmosphere absorbs and reflects starlight. This process, known as spectroscopy, allows us to piece together the atmospheric composition of distant worlds, leading to incredible discoveries like the glass rain of HD 189733b. So, the next time you find yourself grumbling about a little bit of rain or wind on Earth, remember the glass rain of HD 189733b. It's a stark reminder of the wildly diverse and often extreme conditions found on planets beyond our own. On HD 189733b, you'd need more than an umbrella to stay dry. Ever dreamed of watching two sunsets at the same time? Well, let's take a trip to the distant star system of Kepler-16, located about 200 light-years from Earth, in the constellation Cygnus. Here, we find an extraordinary scene, a planet known as Kepler-16b, where the skies offer a view that's nothing short of spectacular, a double sunset. Now, you might be wondering, how is this even possible? The secret lies in the unique celestial configuration of Kepler-16b. Unlike our Earth, which orbits one star, our beloved Sun, Kepler-16b orbits two stars. Yes, you heard that right. Kepler-16b is part of a binary star system, a system that consists of two stars orbiting around their common center of mass. Imagine this. As the day winds down on Kepler-16b, residents would see not one, but two stars, slowly dipping below the horizon, casting long, intertwined shadows across the landscape. The two stars, similar to our Sun but smaller and cooler, dance around each other in a cosmic ballet, separated by a distance less than the distance between Earth and our Sun. But what's more fascinating is the orbital dance of Kepler-16b. The planet takes about 229 Earth days to complete one orbit around its two parent stars. But due to the gravitational influence of the two stars, the orbit of Kepler-16b is not a perfect circle but a highly eccentric ellipse. This means that the distance between the planet and its stars changes dramatically throughout the year, creating a dazzling display of double sunsets of varying intensities. This unique phenomenon of a double sunset, as magical as it sounds, is a reality on Kepler-16b. It's a testament to the incredible diversity and mystery of our universe. Kepler-16b, a world of two suns, where every sunset is a symphony of light and color, a dance of celestial bodies, a spectacle that leaves anyone gazing up at the sky in awe. On Kepler-16b, every sunset is a cinematic spectacle. The universe, it appears, has a flair for the dramatic and the impossible. Our journey today has taken us to realms where the laws of nature as we know them are not just stretched, but utterly defied. Let's take a moment to revisit these celestial wonders. We began with Neptune, where it doesn't just rain cats and dogs, but diamonds. Yes, a downpour of precious stones, a spectacle that is both beautiful and mind-boggling. Then we plunged into the boiling oceans of Gliese 1214b, a water world where the high temperatures and intense pressure transform water into an exotic state of matter, a hot, dense fluid that is neither liquid, solid, nor gas. Our next stop was HD 189733b, where it rains not water, but glass. And not just a drizzle, but a storm of scorching, sideways blasting shards of glass that paint the sky with a haunting blue hue. And finally, we landed on Kepler-16b, where residents, if there were any, would witness not one, but two sunsets. A double spectacle that would paint their sky with an array of colors beyond our wildest imagination. These are just a handful of the countless wonders that await us in the vast expanse of the cosmos. The universe is indeed a canvas of possibilities, a place where the boundaries of reality are constantly being redefined. Next time when you gaze at the night sky, remember, It's not just stars and galaxies, but a canvas of possibilities where the impossible becomes possible.
Subscribe for more videos like this. Turn on notification and leave a like to help the channel out. Thank you for watching.